All right, so here we're dealing with the binomial theorem. Okay, and the binomial theorem kind of explains how you can do binomial expansion. Okay, so that's what we're dealing with here. In binomial expansion, this would be super annoying to have to multiply this out twice, right? So we'd have 2v minus 1 times 2v minus 1, get that, then do 2v minus 1 again. There's got to be a better way. And that's exactly what the binomial theorem does. So it allows us to use Pascal's triangle to do that. Now, a lot of you have been wondering, how far should I go on the, Pascal's triangle? Because I don't want it to take up too much room on my note card. Well, just do this. That's all you need to remember. This is just this. In fact, you don't even need the third line. That right there is enough to actually get you going, because this is the beginning of the pattern. You always, the numbers above here add up to the number below. Okay? So you will always have 1 and 1 here. Okay? In fact, you could look at it as just a bunch of zeros on the outside of this thing. Okay? So then 1 plus 2 is 3. 2 plus 1 is 3. Okay? Next line. 1, 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And you could keep going. Alright, so, you start out with this. If you just remember that you just add the 2 above to get the 1 below, you can generate the whole thing to the 10th, 11th, 20th, whatever you need. Alright. So, with this one then, remember that when you multiply to the third power, you want to use this row. Okay? Now, we can call it the third row. It is the third row. This is the 0 row. Okay? So, 0, 1, 2, 3, 4. Okay? So, the reason being is that if anything, what do we got? 2v minus 1. If we had that to the 0 power, okay, you'd get 1. So, that's it. If you had it to the first power, okay, it looks like you would just multiply 2v times 1 and then negative 1 by 1. So you're going to get the same thing, okay? So that's it does work, but just remember you count it by with 0. Okay. All right. So sounds like the Latvians are partying across the lake, so that means that Obi's going to be barking on and off the entire night. Wonderful. Oops. So sweet. So anyways, we got our 1. So what I'm going to do is I'm going to put 1, 3, 3, 1. And those guys are going to be kind of my my triangle numbers, okay? And they're always there with me. So 1. Now I'm going to have 2v raised to the third power, and the third power comes from here. Then I'm going to alternate, because I do have a negative sign here, all right? I can alternate, so I start off positive, then negative. 2v does get multiplied by itself, so we'll square it. But then 1, not negative 1. It's not negative 1 because we already took care of the negative sign here. Okay? That's what's the beautiful thing here, because you always have to start counting with 1, and so if he's negative, you know he's going to be negative in the front. Okay? So that's to the first power. Then we alternate signs. We go plus, but, oh, missing my 3 here. Okay, we've got to have this guy. So him, him. The next one will also be 3. Okay. 2v gets dropped a degree to the first power, but then 1 gets raised to the second power. Okay. And which is kind of frivolous because 1 to the second power is still just 1. But just keep the pattern pure. So we're going to go 1 again, and that's this guy. We already took care of him. We got that. So then we will have 2v to the 0 power, which is just 1, so we'll ignore him, but then the 1 will go to the third power. But again, he'll be 1 as well. Alright, so here's where I think most of the mistakes happen, is you're wondering why the numbers get large. Alright, well, you have to have 2 to the third. Do not multiply those 2 and then raise it to the third power. In this case, it'll be the same number, but don't do that. Like, you're not going to get 36 here. Negative 3 times 2 is 6. Squared is 36? No. Order of operations going way back to the 6th grade. You always have to do exponentiation first, okay? So you have to do 2 to the second, then multiply by negative 3. You just have to. Alright, so I'm not going to multiply 1 until I raise 2 to the third power. Now 2 to the third power is 8. 8 times 1 is 8. Now the v also gets raised to the third power. Okay? Now if you have trouble remembering that, just remember what you really have. You have 2v times 2v times 2v. I mean, that's going to give you 8, right? So make sure that you understand that this is a simplification of this. This is so tedious to write, especially imagine writing all of those here. It's just, it doesn't make any sense when you can use shorthand, right? This is it. So now we have 2 to the second, 4. 4 times negative 3 is negative 12, and then v goes right to the second. Now I am technically multiplying by 1 to the first power, but this is 1. Okay, next guy. Alright, so 2 to the first power is 2. V to the first power is also v. 2 times 3 is 6. V to the first. And then all this over here is just 1. Now maybe I could have stopped earlier, but I wanted to talk through the process in case the test is a little harder. So it looks like we've got negative 12 plus 6v. We're looking for a plus 1. Made a mistake. This needs to alternate positive, negative, positive, negative. So it needs to be negative. So when we go over here, we can find that it looks like it's got to be the e. Okay, so I got to watch out for that. Made a mistake there. All right. So now we have 1, 4, 6, 4, 1. Those are the triangle numbers for anything to the fourth power. So I'm actually going to have 1, 4a to the fourth. Okay, now negative b, I'm not worried about him right now. So he's at to the 0 power. And then I'm going to alternate. And then I get 4, 4a to the third. But then b makes an appearance. He'll be raised to the first. I will alternate. 6. 4a gets raised to the second, but then b gets raised to the second. Okay, alternate. 4a to the first, then b to the third, and then finally plus 1. 4a is gone. Okay, he dropped the degree to 0. Okay, and then b gets raised to the fourth. All right, so I just simplify this, and again, don't put 16 to the third power. Don't do it. So 4 to the fourth power is actually, it'd be 64 times 4, 256. So 256, a to the fourth, okay, minus 4 to the third is 64. That's going to be 256 again. But now you have an a to the third and a b to the first. Okay. All right, alternate. I'm kind of going to run out of room here, so I'm going to go low here. Plus 16, okay, 4 squared is 16. 16 times 2 is going to be 32. So, well, no, why? No, 16 times 6 is 96. Okay, a to the second, b to the second. Now, I might be done here. I'm not sure, but I'm just going to work through the problem. 4 times 4, okay, 4 to the first power is just 4, and then 4 times negative 4 is negative 16a, but then b is to the third, and then finally b is to the fourth. So that's it. So we look to can't be d. Okay, a to the fourth plus 96a squared b minus 16b plus 6 can't be that. Okay, in fact, can't be this guy. Already crossed him off. Can't be c. Minus 16b to the fourth, that's minus 4, okay, so it's got to be b. Alright? Okay, so minus 4ab, that is not what we got. We got a negative 16, so it can't be that. Okay, so be careful with that. I think the highest degree I'll do is actually probably 6 at the most, but it might be 4 or 5, you know, it just depends.